Hi and welcome to this fifth part of how to create your own Sentinel in Gazebo using ROS Development Studio tools. So I'm Miguel Angel and I'm going to show you in this tutorial how to add these tentacles in a more realistic way, so with interlinks. So let's have a look. So if you remember in the previous video, we made these tentacles with only one type of element. So these connectors with the holes here, right? So now what you're seeing is that each element is connected with a physical connector that in the real model is like this. So how did we do this? So you're going to learn how to do this and also how to add these claws here, activated, so that you can move each finger individually, like this base, what we call the base of the finger and the tip of the finger, for each of the 14 or I think it's 17 tentacles, I don't remember now. So all these tentacles. Obviously you only have to do one and then you'll do the other ones. Okay, so you'll get something similar to, let me show you. For example, we'll create a script called a move sentinel clause that will move all the claws that you say. So you only have to give the number of tentacles that you want to activate. Then when you press, then you have the claws moving, and you can move them independently, just that now we're moving them at the same time, but basically you can move it as you want. And then also, if let's launch another shell here. If we go to Sentinel scripts and we use the Python move Sentinel, we want it's 2 tentacles with I think let me check. So number of elements 3, and you see we can move the tentacles around, and they move really well. This is just giving sign values, but you can see the degrees of freedom that you have with these tentacles, and also you see that the joints are what physically would be, like they revolve around this joint here. So you're going to learn all this, okay? So let's go. Let me stop this. First things first. So what did we do? What did we change to get these elements like this connected, like this element, then this one, and alternating? Well, we did the following. We created the elements as pairs. So an element now is these elements with the holes and the connector. Then another element is these with the holes and the connector. So let's have a look. We have to go to the tentacles, X as always, and all this code, you'll find it in the Git here. You can download it for free, of course. No passwords or anything, just download it. So we go here, and there are some things that we changed here. I'm going to show you. Let's start with the base. So the base elements are these. Let me show. So these 2 elements, like the first connector here and this one is the first element, the base one, let's say. So you can see that here we have this gray and then we have the connector. You see? The connector. And you see that we didn't do any special joints, they are fixed. So these two first elements, let's have a look, maybe this one, we can see it better. So this element and this element are fixed. They are not actuated. This was just to make it easier to then generate the procedurally generated controller files and so on. So this element, first element, that it's made up of this holds element, the gray element, and the connector are fixed, as you can see here. So we go here and we state, hey, we do it fixed, and it's connected to the body. This first element, which is this one, which is the Sentinel shackle gray mesh, which is the ones, these are the holes that have holes. And that's it. And then we connect this one to the connector, which is this one, which is the Sentinel shackle knobbles red. And again, it's fixed and they are connected. This made it much easier to then continue. Once we have the base element, then we have to generate as many elements as we want. So we go to this chakra that we did, which is called the tentacle blah blah blah. So tentacle T1 body link. So this one, it's made up of various elements. So we've changed a bit how the joints are made. So let's have a look. Let's go step by step. So the first one is this auxiliary one, which, as you can see, is just a cylinder. If we go here and we go inside, you can see those cylinders, because I prefer being able to see all the elements I generate and not make them. So you see here that there's like a disc, a black disc. This is the auxiliary link that allows us to turn these joints into spherical joints, which physically they are spherical joints, but in Gazebo you have to do them with a roll and a pitch combination. So in this case, you see that this base auxiliary, if we search for it, we go here, there you go. So this one is the one that connects to the connector, the base connector, which would be this element around here. So this one, this first one connector. So we connect it to this one, and then it's just a plain old disc. That's it. With the joint, which is made of roll in this case. Yeah. Okay. And then we create this base one, which is the ones that have this holes in it, and we connect it to that one. Again, the same thing. We just connect it like this. So here we are connecting this one with the auxiliary, which is the black disc that I showed you. And you see it's a revolute with roll. Instead of roll, it's pitch. Okay? And now this is the new part, the very new part, because now we add the connector. So to the connector, we have an auxiliary element also, and the connector, which is the one that has the mesh. And if you go here, you see, whoops. Yeah. There we go. So if we go here and we try to zoom in, you see that inside there's another black disc, which is the auxiliary one that gives us the roll. So we have those 2 elements. So in total, we have 4 elements that made each of these components that we repeat again and again as many times as we want. Okay? And then we have some details. So the details are how to position the joints. So for that, you need, if we go to the model, you see that, let me show you, for example, this tentacle. So you see that we have to position the joints exactly in where the spheres connect. So this connector with this, let's say this female with this male connectors. And we have to position the joints exactly in that place. So that's the most tricky part, to get the distances right. So how did I do that? Well, I used Blender for that. So if you go, for example, let's see the joints. So you see that in the joints, in each joint, we have tentacle element length to connect it. Then we have tentacle connector element length, because the lengths are different. So if we go, let me show you here. So the distance between this joint and this one is not the same one as this one and this one. The distance is longer. It's bigger here for the connectors. It's longer than with these hold elements, female connectors. So you have to compensate for that. So all these distances is quite difficult to get it right. So the best way is to get Blender and say, hey, let me, I mean, you can do it with SolidWorks on any software that you used for the design of the robot. Let me go here and say, okay, I'm going to get this gray, which is this one with the holes in it. So we put it in orthogonal and we press N, and we see that if we move this around, you get in the bottom left hand corner, you see that you get the distances that you move. That's really important. So let me do it again. This time we set the units and then we import STL and we go here, we get the gray. Okay. So to get the distance between, you see that the origin is here. So we want to get the distance from here to here, which would be the position of the next joint. The only thing that you have to do is move it. Here you can see that if you press G and then Z, you have to see in the bottom left hand corner the distance that you move. So you position this exactly where you want to have the next joint, which would be here. So you get like 6.855 centimeters. And that's the distance that you get and you put in your file. So if we go here and we go to the common properties, you see that here the displacement, for example, tentacle element length, it's more or less the number that we got. So this is the number that I stated for getting the distances between the joints. And with this technique, you can get any distance very exactly, because this is what is very difficult to get the joints in the correct place. Another recommendation that I give you is that instead of doing it with the meshes first, you should try to do it with geometric elements, because it makes it much easier to do this. But that depends on you. Okay? So this is for getting this right. Now for the claws. Oh, one thing. So why didn't we do it procedurally? So use just one element, so here, and then put an if and say, hey, if the element is number 1, then you put this mesh, and if it's number 2, then you put the next mesh, and then you change it again and again. Well, because the if statements in Chakros don't work very well in Indigo version of ROS. So in later versions, Kinetic and so on, it's better, but for Indigo, it's quite limited still. So bear that in mind. So in Kinetic, you'll have more opportunities and maybe you could do it much more efficiently. Now for the claws. So the claws, what I did was, if you go to Sentinel, I added this new chakra, which is called claws. And then what I did is for each of the tentacles, so we had this template that we talked about, and there you go. So here I state that I want 1 claw per tentacle, which makes sense. Yeah. And we use this template, which I called claw, and we give the connector, which, because we designed the robot as we did, it's always connecting to the last element, which the last element is always number 0, which is fantastic. So we give the connector, so we would call it in robotics the TCP here. So we say, hey, the last connector is this one, which is always 0 for the tentacle 1, tentacle 2, tentacle 3, and we connect all this part to it. And that's the claw. And then we give the base name because we need it inside. All right. So we go to claw, and here we have 2 chakras. We have a chakra for the finger. For each finger we have a chakra because it's logical that you repeat. It's exactly the same for each of the 4 fingers, so it would be stupid to not do a chakra for that. And then we have this claw chakra, which is the one we used. So inside this one, we have the claw base, which let me stop the simulation for a moment. So this is the base. This element that connects all the 4 fingers, it's called the cross. And then we have each of the 4 fingers. Yeah. So here we have the base with its mesh. As always, I started with a box with the dimensions. It's very important because that way you get the geometries for the collisions right, more or less. And then you go faster because for the web browser and for the simulator, using simple meshes is much more efficient. It goes really fast. Yeah. And we have this base with the physical properties, and then we have this claw cross with its own mesh, the Shanian Kreuz, I think it's called. And again, we create the joint, so we connect this claw base to the TCP name that we gave, which is this tentacle TCP name that we go here, and was this tentacle number, so T1 00 connector. Okay. We have this connected to the TCP, and then the cross connected to the base with the displacement. So you can see again, these distances, you have to get them from Blender because it's the only way to get them exact. To get the joints where you want, you have to measure those distances. Okay. And then we put the 4 fingers that they are using the chakra finger, and we just change the number of the finger and the position. so that we get them like in the 4, like 0 degrees, 90 degrees, and also the displacement, it has to be different. And I think that's quite it. Once you have that, again, it's really important to measure the distances. So in Blender, you probably have to do the same process. So get here, for example, and then put always the units to get it right. You go here, STLs, claws, and then you go, for example, the shackle, which is the basic element. Yeah, let's say the one that connects to the TCP. And then we import the Kreuz, and you can see here that the origin is in the same place. So we have to G, Z, measure the distance more or less where we want it to be. So around here, it's about 7.7, and then measure, and then put it in your files, in the common properties that we have here. So here around claw cross displacement, yeah, around 8, depends on your measurement, what you want exactly to be. And that's it. And last but not least, how do we move the claws? Well, we create this script, which is called move Sentinel claws. And inside it, we just define these claw fingers and we move it around. So, and this is the last part, which is one of the ones that also gives some problems, which is, okay, we have to move them and we have to generate the control files to be able to move the joints, the claws, but also to move other stuff, like for example, the other joints, the connectors and so on. So bear in mind that you also have to add it inside the generators. So you see here, we have to, this file is the one that it's used to generate this file here, which is Sentinel full control, which is the file that we talked about some videos before, which allows us to control all the claws, all the connectors, all the joints, and so on. So we have to add it inside this file, inside this Python file. So in this case, for each of the 1 tentacles, you need to add the controllers. Yeah, and you have to do it for the 4 fingers. That's why we're doing finger number, range, and we are adding the controller with the name and so on. It's not difficult, it's just that you have to be careful and methodic in this case. And that's it. So in the next video, we are going to talk about how to add color to this magnificent mesh, because we have it already all done. And maybe if we have time, we'll do some locomotion. I don't know. It will be the last video of this series. We leave it here for today. Please consider subscribing to our channel. We publish every day ROS related content. We would love to see your own crazy robotics projects. So post videos, GIFs, or whatever you want in the comments below. Have fun with robots and see you in the next video. Bye!